Hi, I'm Mudinda and I'm here to help you understand maths better for free. In today's video, we're going to be looking at the different first derivative notations as well as some practice questions. This is part 4 of our video series on grade 12 calculus, so make sure you've watched the first 3. Let's get right into it. Last time, we spoke about how if you were given that f of x is equal to 3x to the power of 5 and asked to determine the first derivative, you would denote the first derivative as f prime of x. F prime of x in this case would be equal to 15x to the power of 4. Now, if you struggle with that, make sure to watch part 3 of our video series where we clarify how to derive. But what if we were asked or given the question in the form y is equal to 3x to the 5? What is the correct notation of the first derivative when it's given in the form y? Well, the first derivative, whenever you're given y, is denoted as dy over dx. I know this is a very weird kind of notation you've never seen before, but dy over dx just means the derivative of y. So in other words, dy over dx would be equal to 15x to the power of 4. Let's look at a few more examples. If you were given that y is equal to x squared minus x minus 12 over x to the power of 4, we've seen in a previous video that in a question like this, we'd like to first simplify this fraction. We've learned how to simplify fractions like this. We know you'd factorize that trinomial in a numerator, but what you have to be careful of is that if you haven't started deriving, you need to keep writing y, not dy over dx. We're still simplifying y here. So before we write dy over dx, we're going to simplify y by factorizing the top. I'll put x, 4, 3, minus and plus, just some factorization there. The x minus 4 and the x minus 4 will cancel, and I'm left with y is equal to x plus 3. Now that I have y in the form that I desire, I can start deriving. Now, because I'm about to find the first derivative, now I will say dy over dx. Remember, the derivative of x is just 1, and the derivative of a constant is 0. So dy over dx, the first derivative of y, is 1. Now, y and f of x are not the only forms of notations that you have to learn. There's 2 more. Sometimes you will be given something that looks like this, a funny looking capital dx. Now, this dx is an instruction to derive whatever is inside the brackets in front of it. And so once we are given dx of 12x to the 3, we would say that is equal to 36x to the power of 2. So we note here that dx is an instruction to derive whatever's in the brackets, to derive whatever is in the brackets. Okay, to be more comfortable with this, let's look at some more examples. You see, if you're told to find dx of root x to the 3, this is an instruction to derive whatever's in the brackets. Now, I'd like to rewrite this as x to the power of 3 over 2. But that's not deriving, that's just simplifying or rewriting it in a different form. And because of that reason, I'm still going to write dx, the instruction to derive, and then I'll put x to the power of 3 over 2. I do this because I haven't started deriving. Remember, deriving would be the process of taking the exponent, multiplying it by the coefficient here, and subtracting 1 there. Because I haven't started doing that, I'm still going to write that instruction to derive, because all I've done is just simplify what I've been given there, or rewrite it in a form that's a bit more palatable. So we're trying to find the derivative of x to the 3 over 2. Now that I'm about to start deriving, I will stop writing dx. 3 over 2 and x to the power of 3 over 2 minus 1, which is 1 over 2. Okay, so let's look at another example. Here I've been given dx of x to the 5 minus x to the 3 over x squared. Now I'm going to try to simplify this fraction. Now as I'm simplifying it, I'll keep writing dx because I wouldn't have executed the instruction to derive yet. So in this next step here, I'm going to say dx of, and I'll rewrite this as x to the 5 over x squared minus x to the 3 over x squared. This really helps me because I know now that x squared would leave me with x to the 3 there, x squared would leave me with x to the 1 there. So now I'm just being asked to derive x to the 3 minus x. Now I'm about to start deriving, so I can stop writing that instruction to derive. I'd have 3x squared minus 1. Let's look at some more examples. As I mentioned, there were two more notations, and this is one of them. Here's the last one. D over dx. This is also an instruction to derive, so it works in the exact same way that dx works. Okay, so d over dx of negative 3x to the 4 would be negative 12x to the power of 3. It is an instruction to derive whatever's in the brackets. Now I know it looks quite similar to dy over dx, but as we said previously, dy over dx is what we write when we start deriving some function that was given in the form y is equal to something. This is different to d over dx, which is an instruction to derive. So we're going to note here that d over dx is an instruction. And remember, all these notes you can find in the description box below. Okay, so in the description of every video, I put a link to a Google Drive folder that has all the notes. D over dx is an instruction to derive what's in the brackets. And also note, it's different to dy over dx. Okay, great. So if you're given d over dx of x to the 4 minus 9 over x squared plus 3, well, I'll try to simplify this fraction, right? And as I do that, I'm going to keep writing d over dx because it's an instruction to derive and I haven't started deriving. And so I'll put here x squared plus 3, x squared minus 3. This is because that's a difference of two squares there. Okay, if you ever struggle with factorizing using the difference of two squares method, we have a video up on that. This can cancel that. And so what I'm left with here is d over dx of x squared minus 3. I'm going to start deriving, so I'll stop writing that instruction. I have 2x minus 0 because the derivative of x squared is 2x, but the derivative of a constant is 0. And so the answer there is just 2x. Let's do some more practice. Now, matriculants, if you want to find the full value of these videos, sometimes just pause the video, try the question on your own, see if you get to the same answer first. Okay, so I encourage you to do that for each of these ones. Here in A, we're given that f of x is equal to 3x to the power 4 minus 8 over x squared. Now, I'm just going to fix this by moving the x squared up to the numerator. So f of x here is equal to 3x to the 4 minus 8x to the negative 2. Okay, I'm allowed to move variables up or down the division line as long as I change the sign of their exponents. So now that I've simplified f of x and I'm about to start deriving, I'll start writing f prime of x. So f prime of x is equal to 12x to the 3. And this is going to be plus 16x to the minus 3. Okay, and if you want to be just a bit more concise, we'd rewrite that negative exponent by moving the x down to the denominator to become x to the positive 3. Okay. Now, here in B, I'm given that y is equal to 2x squared minus 3 over 5x squared. Now, as you've seen, with a question like this, where the denominator is just a monomial or one term, I would actually like to simplify by writing each of the terms in the numerator over one of the terms, or over that term in the denominator. Okay, like that. We know now that this x squared will cancel that x squared. Right, so you'll just be left there with 2 over 5. So this is 2 over 5 minus, and I can also move that x up to the numerator to become negative 3 there. So I basically have there 3 over 5 and x to the minus 2. And I can start deriving, so dy over dx is equal to, now the derivative of 2 over 5 is just 0. When you multiply 2 here with the negative 2 with the negative 3 over 5, you'd get positive 6 over 5 and x to the negative 3 because we subtract 1 there, right? Okay, so this is now the same as 6 over 5 x to the power of positive 3. Let's look at more. Here on this question, we're given dt of this stuff. So this is an instruction to derive whatever is inside of the brackets. If I'm just simplifying what's in the brackets, I'll keep writing dt. Now don't be confused by seeing the little t there instead of an x. All that means is we're deriving with respect to t. We're no longer deriving with respect to x. And you'd see there in the brackets there that our variable is no longer x, but it's t. So don't be confused. We're going to do the same thing. It's just that instead of x, we're talking about variable t. So dt of, and I'm going to factorize the top there. It's a difference of 2 squares. I'll put t plus 1 and t minus 1. In the denominator, there's a common factor of 2. If I take it out, I'll be left with t plus 1. Okay, now the t plus 1 can cancel the t plus 1. I'm left with dt of t minus 1 over 2. Okay, now I might want to rewrite that as dt of t over 2. Okay, t over 2. All right, minus 1 over 2. Okay, but now remember t over 2 can also be written as just 1 over 2t. Okay, 1 over 2t. That's all it is. Now, what is the derivative of 1 over 2t? It's just 1 over 2. Remember, the derivative of just t would be 1. Okay, so the derivative of that is a half, and the derivative of this is 0 since it's a constant. And so that's what we get as an answer. Okay, let's look at a few more. All right, so here, again, this would be an instruction to derive, and I'm going to try and simplify whatever's in the bracket. I have that situation again where I have a binomial in the numerator and just one term in the denominator, or monomial in the denominator. So I'd like to write 2x to the 5 over x to the 4 and then minus 3x to the 3 over the same thing. Okay, so before I derive, I must keep writing d over dx. 2x to the 5 over 4x squared minus 3x to the 3 over 4x squared. Now we know that this x squared term can cancel 2 of those, and there we're left with x to the 3. This x squared there will leave us with x to the 1. So essentially what I have is d over dx of 2 over 4 and x to the 3 minus 3 over 4 and x. Now, the derivative of that would be 6 over 4 x to the 2 minus just 3 over 4. Okay, and let's simplify this fraction here. It's 3 over 2, not just 6 over 4, but 3 over 2. This would be your final answer there. All right, let's do a few more examples. What if you had here that y is equal to x to the 3 over 2 minus x to the half over square root of x to the 3. Pause the video and give it a try. So the very first thing that I'll do is I'd like to change that denominator into a form that's a bit more palatable, or something I can work with a bit more. So I'll write it as x to the 3 over 2. Then I'm going to write x to the 3 over 2 over x to the 3 over 2 minus x to the half over x to the 3 over 2. Okay, now this just cancels away and I'm left with 1, all right? So y is equal to 1 minus x to the power of 1 over 2 minus 3 over 2. So I'm just applying the laws of exponents here. Like I said, if you struggle with them, we do have a video up on them. It's quite good, if I do say so myself. So give it a watch. But now that I have that, I'm going to simplify it to be 1 minus x to the power of A half minus 3 over 2 would be negative 2 over 2, which, yeah, negative 2 over 2, which is negative 1. Okay, now I can start deriving. So I write dy over dx. The derivative of 1 is just 0. It's a constant. The derivative of this guy, I'm going to take minus 1 multiplied by that minus there to become positive 1, and x to the power of negative 2, right? Because I must subtract 1 there. So this is the answer, x to the negative 2. And to be more politically correct, mathematically correct actually, that will be 1 over x to the 2. Okay, awesome. So that's the last example there. Now, grade 12s do give deriving a lot more practice because it's really just the fundamentals of calculus. In the next video, we are going to be talking about stationary points. We're going to be talking about stationary points and also what a derivative actually is. And spoiler alert, a derivative of a function is actually the gradient of a function. See you in the next one.